Okay, friends, this is the second video of Coulombs law. In this video, we will learn the concept of permittivity. In previous video, we have learned this formula that Coulombs constant K is equals to 1 by 4 pi epsilon. This epsilon, I told you that this epsilon is called permittivity. Now, what is permittivity? Now, permittivity, you just break the word permittivity. It comes from permission. Now, permission for what? Every medium has an unique characteristics that it gives certain amount of permission of two sets of charges to interact between them. For instance, for example, I have a medium X and I have a medium Y. Medium X gives total permission between two charges to interact between them. But medium Y does not give the permission to interact between the charges. That's permittivity. So I have written it like here. It is the characteristics of a medium which affects the force between two charges. Now, we have learned this formula previously, that Hc is equal to K into Q1 Q2 by R square, and we can learn it also easily. Two important things: unit dimension of permittivity. It is this. You can easily derive it from here. You guys know how to derive dimension. And unit of permittivity is Coulomb square Newton inverse meter to the power minus 2. This is very important. Learn it and you know how to derive it. And also another important thing, the unit of Coulomb's constant K. Look, K is 1 by 4 pi epsilon, and unit of K is also different. It is actually reciprocal of the unit of epsilon. This is Newton meter square Coulomb to the power minus 2. These three things we have to learn. These are very important things for your exam point of view. Now, value of epsilon, we have to mark up this value for free space. This value is required for numericals. It is 8.854 into 10 to the power minus 12 SI units. It is actually in SI. And another important concept we are going to learn here, that is relative permittivity. What is this? Fm, it represents a Coulomb force in a certain medium. Say X, Y, Z, any kind of medium. We can write it like this: 1 by 4 pi epsilon medium. This is the permittivity of that medium into Q1 Q2 by R square. And F naught, this is naught means free space. We will represent free space as naught by naught. F naught, Coulomb force between two charges in free space. It is 1 by 4 pi epsilon naught Q1 Q2 by R square. If we take the ratio of F naught by F naught and Fm, we will get here epsilon m upon epsilon 0. This ratio, epsilon m upon epsilon 0, we term this as epsilon r, relative permittivity. So it is the ratio between the permittivity in a medium with respect to free space. Permittivity of free space. Another thing, some simple calculations, that from here we can easily say Fm by F0, F naught, is epsilon naught upon epsilon m. Fm, we can write it here as epsilon naught upon epsilon f into F naught. And We know epsilon m upon epsilon naught is equals to epsilon r. We have written it here separately, and we can easily write epsilon m, permittivity of a certain medium, is equals to epsilon r into epsilon naught. That means permittivity of a certain medium is equals to relative permittivity into permittivity of the free space. Thank you.